So as I promised you to prove the formula n factorial divided n minus r, the permutation formula. So the theorem, let me first read and then we'll proceed. Okay, the theorem is saying the total number of permutations means arrangement of set of n objects, all right, taken r at a time is given by P and R, n times n minus 1 times n minus 2, that's n minus r minus 1. And always you have to remember n is always greater than or equals to r, and that is also equivalent to n factorial divided by n minus r. This we have used in the previous video, and I'm going to show you how it is. But before discussing the theorem, I just want to take you to the fundamental principle of counting, and there according to that I will try to make you understand, right? Let's say again I have 4 color boxes. First one is red, second one is white, third one is green itself, and the fourth one is pink. And I want to fill these 4 colors in 3 different boxes, alright? And every time I need 3 different colors. So what is the total possible ways of coloring these 3 boxes? And every time I need 3 set of colors. Like you cannot repeat the color, you cannot make the 2 boxes or 3 boxes with same color. So how we can fill this? Let's say this is first box, this is second one, and this is third one. So let's just start filling with the first one. So to fill the first box, I can choose a red one, I can choose white one, I can choose green one, I can choose pink one, I can choose any one. So I have 4 options. And once I'll fill this first box, let's say for a while I fill this pink color, right? So I fill this with pink color. So now we are left with 3 different colors to fill in the 2 different positions, alright? So to fill the second position, I can choose red one, I can choose white one, I can choose green one. It means I have 3 options, alright? Let's say I'm going to fill with red one, alright? So red is also dead now, we cannot repeat again. So we have now 2 colors to fill single position, alright? So we have 2 options. Let's say for a while I fill with white one. So the total possible ways of filling this 3 boxes with 4 colors is now 4 times 3 times 2, that is 4 times 3, that is 12, 12 times 2, 24. So there were 24 ways of coloring these 3 different boxes with 4 different colors. Now in the exactly same way, let's say for a while we have here n number of objects, alright, and we have here r number of boxes for a while, alright, r number of boxes. Let's say this is our first box, this is our second box, this is our third box, dash 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 dash, and this is our rth box. And that we're going to fill with n different colors. We have so many different color boxes, alright, a lot of colors we have here, alright. So if you compare now exactly with this, when we were filling the first box and when we had only 4 color boxes, that time, you know, we filled the first box with the 4 different colors. So here we have now n number of color boxes. So first position can be filled with n number of colors, and you know, once we fill the first position, then we'll get shortage of 1 color because we cannot repeat the same color again, alright, and we'll have total option of n minus 1 that time, right? Now we have only n minus 1 color boxes. So to fill the second position, now we have n minus 1 options, n minus 1 number of colors. From them we can choose any one. To fill the third one, we have n minus 2, alright. Similarly, as we can fill with so many different colors, alright. Let me arrange a little in one more proper way. For the first position, we can fill by n. This is n, alright. So n minus 1 minus 1 I'm doing for myself. 1 minus 1, that's 0. And for filling second position, I can write n minus 2 minus 1. If I'm writing 2 minus 1, then what happens? 2 minus 1 is 1, and which is here, right? And for the third position, I can write n minus 3 minus 1, alright? This is for the third one. In third, you can see n minus 2 we have, and 3 minus 1 is also 2, alright? So in a similar way, in the rth position, if you go, what you can write? See, in the first position, n minus 1 minus 1. In the second position, n minus 2 minus 1. In the third position, n minus 3 minus 1. So in the rth position, it will be n minus r minus 1, alright? I just want to show you, this is first position, so you have 1 here. This is second position, so you have 2 here. This is third position, so you have 3 here. So this is rth position, so you have r here, right? I just want to show that. So I can say now that the total number of ways of filling n different colors at r different places is n times this thing times this thing times this thing dash 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 times this thing, just like 4 times 3 times 2, and then answer. We just have to multiply. So this is just giving us the total way of arranging n different colors at r places, and that's what the permutation is. The total permutation of n objects taken r at a time is this one. All right, so I'm just writing a little in a proper way. NPR, which we also write like this. PNR can be written like this. It's n. Now 1 minus 1, I'm just writing n, and this is n minus 2 minus 1, so I can write this is n minus 1, and this is n minus 2, and this is n minus r plus 1, because minus will multiply this minus and you will get plus. All right, that's it. All right, I think we got the first one. Yes, we got till here. And every time n is greater than or equals to r, right? Keep in mind. And I want to work out a little more here to get the better result. All right, let's say I have here n minus 1, n minus 2, dash 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 dash, n minus r plus 1 I have. All right, and what I'm doing, keep in mind now, from here I'm going to multiply and divide by something. N minus r minus 1 dash dash dash, 3 times 2 times 1. And exactly with the same thing I'm dividing also. N minus r minus 1 dash 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 dash, 3 times 2 times 1. Okay, and my dear friend, you just tell me here, what do you mean by 3 factorial? 3 factorial means the continued product of the first 3 natural numbers, 3 times 2 times 1. So my dear friend, can you tell me what is it looking like? I cannot figure out properly. My eyes are really poor. It is n times n minus 1 times n minus 2 dash 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 n minus r plus 1 times n minus r times n minus r minus 1 times 3 2 1. Oh my god, this is the continued product of first n natural numbers. It means this is n factorial. Oh yes. And what is this? N minus r times n minus r minus 1 times dash 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 3 times 2 times 1. Oh my god, this is the continued product of n minus r, first n minus r natural numbers. So this is n minus r factorial. That's it. And this is p and r, and that is what we need to prove. So this is the proof for permutation formula. So now we can easily say that whenever we have to arrange n different object at r different places differently, then we can easily use this formula. Or you can say permutation of n objects taken r at a time is n factorial divided by n minus r factorial. We have deriving this formula. Now you can use easily. All right.